Welcome back. As you know, I am Eli the Computer Guy, and this is Silicon Dojo. Silicon Dojo, authorityless, gatekeeperless, free to the end user, hands-on technology education here in Asheville, North Carolina that empowers our students to do what it is that they want to do. Please remember that one of the key concepts of Silicon Dojo is train the trainer. When we create our educational program here in Asheville, North Carolina, we want to make this freely available to the public, not simply so that individuals can learn the information that we're trying to teach, but they can actually learn it to the level so that they can teach other people. So our slide deck, our code, these videos are all presented for you for free so that regardless where you are in the world or who your audience is, you can present these same types of classes in your own facilities. And the final bit of the spiel is, do remember, free to the end user is not actually free. The rent on our facility costs money, computers cost money, internet costs money, insurance costs money. My golly, so much crap costs money. So anyways, we do work for tips. Basically, what we're trying to do is make this program a crowd-funded model so the people that do find our information valuable and they are able to throw money into the pot, they throw money into the pot to keep this whole thing going, and the folks, for whatever reason, who do not have enough money can still actually get some education. So if you do like the programs that we are creating, if you find value from this particular video, there is a donor box link or such probably down below or to the side or somewhere around this video. It would be wonderful if you clicked on that and threw in a few dollars per month. So today's class is Introduction to tKinter. So tKinter is a great framework for Python that allows you to create GUI applications, basically graphical user interface applications. So this gives you buttons, this gives you text boxes, this gives you list boxes, this gives you all of the stuff that noobs think of when they think of interacting with a computer. It is very important for us. This is actually our second hands-on class that we've done here at Silicon Dojo, and the reason for this is I want to get our students to the point where they're building things that look like applications as quickly as possible. From an educational standpoint, one of the problems we have with teaching education in the real world is so many times students learn things, but they think of it as academic, they think of it as abstract. They can't really understand how this thing that they learned relates to how they use computers in the real world. So imagine sitting there at the command line and you create some big old Python script, 100 to 1,000 lines of code. You run that Python script, it goes out to an artificial intelligence API, it goes out and grabs pictures, it does all kinds of fancy stuff, and then the user, the student, simply gets some text output at the end. One of the problems is that may be a very powerful program that they created. It may have taken a lot of technology skills to create all of those lines of code, but when they get to the end of it, they can't really relate this text output to something that they would use in the real world. So one of the nice things with jumping into tKinter relatively quickly is this gives students an output and an interface that looks like a computer to them, right? So when you, instead of simply printing out onto the console to the command line, now you're printing out into a text box, right? When you're going to be giving options to your script, instead of simply adding options in a list or something like that, you can have a list box that allows you to submit options, or it can read from a text box or an entry box or something like that. So one of the really powerful things about tKinter is it's a very simple way to get students to start building things that look like what they would consider real technology. The nice thing about tKinter is that other than the framework that again is the built into Windows and Mac and you can very easily install into Ubuntu, other than that framework you don't need anything else. So I like Django. I like Django is a web framework for Python, allows you to create very sophisticated web applications relatively quickly once you understand what's going on. Here's the thing. I was sitting there trying to figure out how to create an introduction to Django class. Oh my golly. You have views files and URLs file. You have so much going on just to get Django up and running. And then you have to start sending things between files in the database and everything else, right? Like literally, in order to do an introduction to Django class, it's going to be at least 8 hours, and there's going to be a lot to it. One of the great things, and we're going to see this in our first lesson, is with tKinter, you install tKinter, you write 4, 5, 6 lines of code, and hey, you got your first tKinter application. It is that easy. And so that's one of the things that I really like about tKinter, especially from an educational standpoint, is we can simply jump in to having that front-end user interface without having to have days and days and days of previous education and understanding how all of this kind of stuff works. So anyways, we're going to be dealing with tKinter today, and I think you're really going to be enjoying this class. So here's where I say my new quote for the next decade. I feel like I have a quote that I use over and over again for numerous years until I move on to the next thing. The quote for the next decade for me is, I barely get paid to teach you people. I sure as hell don't get paid to troubleshoot your crap, right? One of the things, if you're going to be taking these classes online, just to realize is you are dealing with computers, and you can write code perfectly and still have it not function properly because of permissions or out-of-date modules or something like that, right? Here at Silicon Dojo, we have standardized on 2012 MacBook Pros. So to be clear, a 13-year-old MacBook Pro actually works great, and we install Ubuntu onto these. So we go to a website called backmarket.com. Depending on the day, it's not really an auction system, but anyways, the prices go up and down. It's anywhere between $130 to $150 for one of these old MacBook Pros. I then go to Amazon.com for $30. I buy a 256 gig SanDisk, again SanDisk, not one of the crappy ones. 250 gig hard drive for about $30. Basically, put this into our old MacBook Pro, and then we installed the latest version of Ubuntu. Currently using, was it Ubuntu 22.4.2, something like that, the long-term version. And that is the environment that we're using in order to do this type of code. So if you're at home, again, it is a real thing. Like, one of the big problems you see with a lot of new people in technology is they sit there and they write the code perfectly and they do everything right, but then something else fails. And again, they get very frustrated because they think what they're doing is wrong, and like what they're focused on is wrong, when it's really something else that's wrong. And then at some point they put up their hands and they give up. Again, they do not fail, they give up because they can't figure out what's going on, and it's a bit of a disaster. One of the things with our educational system is I really want to streamline everything down to the point you are learning and dealing with the subject that we're talking about. You're not dealing with a whole bunch of other crap that we're not dealing with at this point. So just to understand, this is the environment we're using. Again, I like the MacBook Pro, 2012 MacBook Pro. Also, for classes we'll be doing in the future with things like computer vision, the webcam works on those old MacBook Pros by default. Also, if you're dealing with things like server operating systems, one of the things that's nice is it has a built-in network card. Even if you're not going to be using a 2012 MacBook Pro, I would recommend you use Ubuntu. If you're following along, that's going to be the closest. Again, it's going to be the same operating system environment. So it should, more or less, follow along with what we're doing. If you're just going to use your computer, well, you might run into some problems. The last class that I did, this class with tKinter, we had a professional programmer, been doing programming for 15 years, had a fancy, $3,000 brand new MacBook Pro. He was like, why am I going to use some 11-year-old piece of crap when I have this beast? And he spent a good bit of time actually troubleshooting his beast because it didn't work properly. So that's just one of those things to kind of keep in mind. One of the things that I'll show you is that if you're having a problem running tKinter, especially on your Mac, you might actually need to flush out the cached settings. So again, I have one of the cheese grater MacBook Pros at home, or Mac Pros at home. I have a MacBook Pro, and I was working with tKinter with that. And one of the interesting things that I found is when I tried to run these scripts using the run command within VS Code, one of the things that would happen is tKinter, the application would open up, but it would be a completely black background. Or I ran into issues where widgets wouldn't show up. So the label widget or the text widget wouldn't show up if I ran it from VS Code. The interesting thing is if I ran it from the command line, from the terminal, so Python 3, whatever the code was, it would work perfectly. What I found out doing a bit of troubleshooting is that basically VS Code was using Python 3.8 and my Macs were using Python 3.10, and so that's where the issue is. If you run into that issue, right? So again, you've got a Mac or you got Windows, you're just like, Eli, I'm gonna do what I'm gonna do. Because that's what students always do. Why would students listen to the teacher? Eli, I am not taking your class to listen to your advice. Don't be stupid, Eli. Anyways, you're using your Windows or your Mac. I know this works. If you're running these kinds of problems, go up to View on VS Code. Go up to View. From here, click on Command Palette. This will get you this. This may by default be at the top of your VS Code, but if not, go to View Command Palette. From here, I want you to type in clear, C-L-E-A-R, and then with this, when this shows up, scroll down and you'll see Python, clear cache and reload window, clear workspace interpreter settings. This is the main one actually. Clear the workspace interpreter settings, because I guess it caches that old interpreter, that 3.8. So you do this and hopefully, if you click on the play button, VS Code will work properly. I would also say just do the clear cache and reload window, and if you do those two things, that hopefully will make the tKinter applications work for you properly if you simply click on the play button. If that doesn't work, again, from what I've seen, simply go to terminal, call the script from the terminal itself, Python 3, whatever the script name is, and that should work properly. This is the perfect example in the technology world of why it's so difficult to teach new technology professionals, because you want to focus on tKinter. Like, what I want to focus on is this, but to get you to the point that this actually works, you have to start troubleshooting interpreters and operating system problems and all that kind of stuff. So again, there's a reason I believe in standardization. So if you're going to be following along with these classes at home, or if you're going to be building a lab for your students, I would highly recommend you find one type of hardware. And again, Ubuntu is a great operating system, but one operating system, and just stick with that for teaching folks. So it's about time to jump into this class. Now you'll see me holding this paperwork. This is our workbook. One of the things with Silicon Dojo is I believe in kind of a paint by numbers education system. So I created this workbook, and you can download this and you can print it and reproduce it and do whatever you want. There should be a link down below this video, most likely to Silicon Dojo or to GitHub. From there, you'll be able to download all of the code samples, and you'll be able to download this workbook. And if you're going to be following along, I would recommend that you print this out, just so you can follow along with everything that I'm talking about here. So again, if you're dealing with Mac OS or if you're dealing with Windows, tKinter should already be installed by default. Should. You'll notice words that I use. Should it be installed by default? If it's not installed by default, you get to troubleshoot that mess. With Ubuntu, again, kind of ironically, since this is our lab computer, you do actually have to install tKinter onto Ubuntu, but it's dirt simple. Sudo apt install, so not pip, apt install, sudo apt install python 3-tk, and that will install tKinter onto your Ubuntu system, and everything should be good from that point. So you shouldn't have any other problems. So that's basically where we're at, and so let's dive into the code. So our first lesson, lesson 1 obviously, is the good old-fashioned Hello World app. So as we're starting off, what we want to do is we want to make sure we understand the basic functionality before we start building on that basic functionality to create more complicated applications. So with this, all we're going to do is we're going to have a window that pops up and says Hello World. And let me just show you how this works, right? So we're going to hit the play button. We're going to hit the play because this works properly on the Ubuntu. And when I do this, we get this nice little, look at this, we get a little nice GUI window. My first app, Hello World. Yay! We're creating GUI apps already. Again, we have a minimize, we have a maximize. I don't know what you do with that. And you have a little X over here, and it's a pretty simple application. So let's keep this over here for a second, and let's just go through this code. So the first thing that we're going to do is we're going to say from tKinter import all. So we're going to be importing all of the functions from the tKinter module. When you actually go out there to start building applications in the real world, you probably don't want to do this. You probably simply want to add the specific functions that you're going to use from a security and a reliability standpoint. But we are here in a teaching environment, so I'm trying to teach you how this stuff works. So we're just going to import everything. From there, we're going to use the tk function, uppercase T, lowercase k function. And this function is what creates a window for us. And we're going to create a variable called window. So window is going to equal tk, right? So basically, just like you have a data type of int or string or whatever else, this is kind of like a data type of window. I guess it's an object, really. And so we're going to be creating that. Then down here, we do window.geometry. So geometry gives us the size for the window. Double quotation marks, 400 by 50. So 400 is width, 50 is height. If you put in the numbers here, you do have to put a double quotation mark. You can feed these numbers in from a variable if you want to create that somewhere else, possibly dynamically. But when you put this in here, it's more of actually a string than it is numbers, how you normally deal with it. Just don't forget the double quotation mark. So 400 x 50, so 400 by 50 high. Window.title is my first app. So we see the my first app up here. That is the title. Then we're going to create a label. So we do the LBL. So we're just creating a variable name for label called LBL. We're going to use the label function. Now here's one of the interesting things. So in the tKinter world, placement is very important. Again, remember in programming, nothing happens magically. Like people think that there's some kind of magic that happens. It doesn't. Everything makes sense. Everything's logical. So one of the things you have to do is you have to tell tKinter where a widget. So when we talk about a label, so a label is a widget, a text box is a widget, a frame is a widget. Basically anything inside the tKinter box is a widget. So we have to say, where is this widget going to go? So we're going to say widget, this label is going to go into window. So with this, you could have 5 different windows open. So I could create 5 different windows, and based off of some event, I could have something pop up on, one of them, right? So it has to know where is this going. So it's going to go to window, and then we're simply going to say text equals hello world, and that's going to be the label. After that, we have to pack it. So packing is the function that actually puts this label, this widget, onto the tKinter window that we've created. So we just simply do LBL, or whatever the variable name is, period pack. Now with pack, there are options that you can put in there that we're not going to worry about today. Pack is its own interesting thing when you go to actually format the widgets that will be put into the tKinter window. Just realize we're not dealing with that today. The final thing that you have to do, and this is probably where you're going to screw up if you run this and it doesn't work properly, is window. So window.main loop. So what the main loop function does is it actually says all of this is part of the main loop to run. And so when this script is called, actually run all of this as part of that main loop function. If you don't put this here, nothing else works. It's kind of like when you start writing scripting like PHP, you open up the PHP tag and you close the PHP tag, and especially when you're brand new, you always make sure that you do that. One of the things that you might want to do when you start coding in tKinter is open with the from tKinter import all, and then immediately put window.main loop, and then fill in the middle. That might be a good way for you to make sure that you don't forget anything. But anyways, this is our nice little Hello World app. So if you write this out, save it. I just save it as like 1.py. That makes life easier. Run it, and this is what you'll get. Now we get to lesson 2 and we start to do a little bit of formatting, right? So one of the big problems we run into when we have new people and they start playing around with tKinter is they see these drab gray windows. They see this very basic black text and they go, ew, that's old. I don't want to use old crap, and then they run off to learn React or something that's supposedly cool. One of the big problems that we run into is people like me code using something like tKinter, and it looks ugly as hell, regardless of how powerful it actually is, and so new people just discount it because it's not fancy using the modern colors or whatever. So one of the things I do want to show you here is that you can do formatting with tKinter. So we're just simply going to format a label. We're going to do a label widget here. We're going to format it with a red color. We're going to format it with a raised buttony taping look, and we're going to format with a yellow background just to show you can do more complicated formatting with tKinter, even though most of us probably aren't going to do it at the end of the day. This is a big thing to be thinking about when you go out there and you start trying to develop applications, is something that gets overlooked, especially by new people, is that UI UX designers, so user interface, user experience designers, they actually do a lot of work. Right? There's this kind of this feeling like the back-end developers are the real coders, and then the UI UX people are kind of like parasites or whatever that feed off the real work. Let me tell you, taking an ugly ass application that a Linux admin created and making it something pretty for modern audiences to appreciate, that actually takes a lot of work. And so this is something to also be thinking about when you're planning the time frame for developing your project, making sure you actually add in enough time for making your user interface pretty. Half your time is going to be spent on making your user interface function. The other half of the time is making it pretty and usable and all that kind of stuff. So if you say, oh, it'll take me 100 hours to develop this app, make sure to add 50 to 100 more to make the app pretty. Anyway, so we're doing lesson 2 here, label formatting. Let me run this so we can see what's going on here. And so this is basically what we got. So we got formatting labels. So that's the title, like I showed you how to do before. We have default formatting. So this looks like the label that we had before, just with the default text. We then have red text. Woo! We then have raised blue text, just to show you can add some multiple formattings to one label. And then we have text with yellow background. Again, this is all just very simple. This is about as far into UI UX as I want to get, but it shows you that you can do this with tKinter. So from tKinter, import all as we did before, and down at the bottom, make sure to do main loop. Main loop, window.main loop. Start with tKinter import, end with main loop. Always remember the main loop. You're like, Eli, oh crap, I need to ask Eli a question because my code's not working. Let me answer it. Main loop. I did this in class the other day. Every time somebody had a problem, they forgot the main loop. Always do main loop. So from tKinter import all, window equals tk, so the tk function, uppercase T, lowercase k. Window.geometry for this is 400 by 100. Yeah, when I got rid of that. Oops, where is it? Give it back. There we go. 400 by 100. So you notice before it was 400 by 50. So I needed this to be a little bit taller. So I made it by 100. Window.title, we changed it to formatting labels up there. So then we have label 1, label 2, label 3, and label 4. Label 1 equals label window. Where is it going to be? It's going to be in the window. Text equals default formatting. We do nothing else to it. We pack it, label 1.pack, and that's what puts it on the screen for us, and we simply get black text. Label 2 equals the label function, window, text equals red text, foreground, so FG is foreground color, background color, foreground color, FG equals red. And that gives us red text. Label 3 equals the label function again. In window, text equals raised blue text. Foreground equals blue. Relief, so that's basically whether it's raised or not. Relief equals raised. And so that gives us this thing that looks like a button. And again, when you think about UI, UX design, be careful about making things look like buttons. If it looks like a button, but it isn't a button, the user's gonna click on it 1,000 times. Anyways, I would not do this in the real world, but just to show you that that's possible. Then we have label 4, LBL4 down here. Let's see here, label 4, LBL4 equals label, in window, text equals text with yellow background, BG, as in the background color, equals yellow. Then we are going to pack LBL underscore 4 dot pack. That puts it here. And there we go. We have a little bit of formatting for the labels, and you start to get the idea of how tKinter works. Again, always remember the window.main loop. Whatever you call this, you can call this a different variable name. You might see it like when you go and look at examples, many times people might say root. So they might do root equals tk, or they might do top equals 2k, or maybe parent equals 2k. We're just doing window. I don't know. It's just what I decided on. So window.main loop is here. And then make sure you do this packing. So this creates the variable for the widget. We're currently using label widgets, but this creates the variable for the widget. The packing function, the packing is what then actually puts that into the TK window. So do make sure you do the label or whatever widget dot pack to make sure it's there. If it's not there, you most likely forgot the dot pack. So now we're at the point in the class where you get to start clicking on things. Again, if you're a teacher out there, you're somebody who wants to be an educator, what I will tell you is the faster you can get your students to be able to click on things, the better your class is gonna go, right? We're only at lesson 3 and we're already gonna start clicking on buttons. So basically what this is going to do is this is going to give us a button that we can click on, and that's going to open up basically something like an alert box to show us a message. And this will kind of give us the idea of how the flow of a basic TK application is going to work. So again, just so everybody sees what's going on, we have this. I'm going to click the run button over here, and this is our app. And so we see we have a title. So we have a button app title like we had before. We have click a button, which is a label that we've had before. We have warning info. Ooh, that sounds kind of cool. And then we have the exit button. So what the exit button is going to do is that is going to allow us to easily get out of TK. So that's probably going to be one of the things that you're going to add into almost every single window that you create with TK, just because it makes your life a hell of a lot easier. So anyways, let me run this again. Again, we have this warning info. And so what happens if I click on warning info is I get a warning. Warning, warning. This is a warning message, right? Anyways. You got a button. The button basically fires off what is called a function. So if you're new to the coding world, what a function is think of it as like a little programming within the programming language. So when you want to do a specific task, you would then call a function, and that runs an amount of code to make something happen. So we click on the button, that calls this function, which creates this alert box for us, and we say, see, ooh, this is a warning message, right? So this kind of, it gives us a little bit of functionality here. Part of this With this is I can click OK. There's always that OK button, and then we go back to this button app right here. So anyways, let's talk about how this actually gets coded, right? So from tKinter import all, as we've seen before, and before we forget, window.main loop. Window.main. Import window.main loop. Always do that. And then, of course, because this is the technology world. I mean, when you import all, it doesn't mean you actually want to import all, does it? Anyways, one of the widgets that we're going to be using is the message box, right? So when we click on warning info and we get this message box, that is a different type of widget, and we have to import that separately. Why? I don't know. I don't know. Our industry is full of very passive-aggressive a-holes. It's not my fault. Again, this is an interesting thing you're going to run into in Python, in general, but specifically in tKinter, is when you're going to import what you think is all of the functions for tKinter, what you're going to find is many times all is not actually all. And so if something isn't working for you, you might actually have to import it separately. Don't ask me. It's just how it is, right? So anyway, we're going to have to import messagebox separately. Okay, window equals tk, as we've done before. Window.geometry is 400 by 100. We've gone through that a couple of times. Window.title is button app. So button app, right? You should be pretty good with that at this point. Then we're going to create a label. We're going to create a label. The label name is going to be LBL. The label equals label function in window, text equals click a button, and then we're going to lbl.pack. So this creates that label widget, and then we're actually packing it using that function to put it on the page. And then what we're going to do down here is we're going to create the function. So when somebody clicks on the message box, we need to create the function for what happens. The function has to be in the code before it gets called. So this is the warning info button. So this button right here, button, is this. This calls the warning function, but for this to work, the function has to be before the button in the code. One of those things when dealing with Python is so whenever you call something, you can't just kind of willy-nilly dump it into the code. It actually has to be before whatever is calling it, or you'll get an error. Right here, we're simply going to create a string variable, message underscore warning. This is a warning message, right? So since this is a variable, right, we could pull this from, let's say, the CPU. If CPU processing goes above 90%, if disk utilization goes above, 80%, something like that, we could pull this value from somewhere else, but we're just creating a static string right now. Then in order to create the function, we're going to create a function just like you always create a function within the Python world. DEF, so think of this as define, space, and then whatever your function is called. So this is going to be called the warning function, open parentheses, close parentheses, because we're not sending anything to this function, and make sure you put a colon there. Then what we're going to do, tab in message box dot show warning. So this can be show warning, show error, or show info. Just to show you this, right? So show info actually gives you a different outcome. Warning info. Oops. Did not allow me to save. Oh well, it's not allowing me to save. We're not gonna get into that right now. Anyways, just so you know, this can be show warning, show error, or show info, and it gives you a little bit different graphic whenever you do one of those. Again, I screwed up the permissions here. I copied and pasted from my Mac onto this Linux box, and when I didn't change the permissions of the files. So therefore, when I'm trying to save, it caused an error, which means I'm not gonna go there. I barely get paid to teach you people. I don't get paid to troubleshoot. So anyways, just accept what I'm saying here. Anyways, so message box. So the message box function creates a message box, show info, show error, show warning, whichever you decide. Then we're going to say warning or whatever. We're going to say some text here and then do comma. So we're concatenating on. So we're concatenating warning with the variable value of MSG warning. And that is going to give us that message box, right? So we click on this. We click on warning info. That then gives us, right? So message warning equals, this is a warning message. And so this is what we get. So, then, you ever have one of those days? Oh my golly, what's going on? What's going on? Oh, if I like to edit videos, if I was actually somebody who edited videos, I would be doing some editing today. But I don't like to edit videos. That's not the kind of geek I am. Oh my golly, what the hell is going on? Oh, this would be funny. This would be funny if it wasn't so serious. Okay, stay, computer. Stay. I leave this kind of stuff in just so you see. It happens to everybody. Anyways, let me just get rid of that. Let me discard that change. Okay, so then we go down to the warning button. So the warning button is what's going to call this message box. So btn underscore warn. So one of the things too with tKinter, remember everything is in text. So you do got to make sure logically you can keep track of things. So you'll notice I call labels LBL variables, buttons BTN variables, so on and so forth. This allows me to keep track of what the hell I'm dealing with. So the btn underscore warn button equals the button function in window, as we've done before, text equals warning info, and then command equals whatever function we want to have fire off. Now you'll notice there are no parentheses at the end of this function. We're just simply using the name itself. Warning, we'll show you in a second, destroy, whatever. We just use the function name, no additional parentheses. Then under this, we do btn underscore warn dot pack. So we create the button here, and then we pack the button here, and that's what gives us our button. Then under this, we're going to create a second button so that we can close our windows, just to make life easier, right? Button underscore, or btn underscore close equals button in the window. Text equals exit, command equals, and so destroy is a built-in function. So we're going to say window.destroy. So this will destroy the window, right? Basically, it'll close it. Then, of course, we're going to pack button under btn underscore close dot pack, and then we're going to do the main loop. Don't forget the main loop. And when we do all of that, that is when we get our buttons. That is when we get our buttons. So anyways, all relatively simple there. I think the place that will get you into trouble when you start playing with this is do make sure your function is always before whenever you call your function within the script. If it is afterwards, you'll run into this error where it says like you're calling something that has not yet been defined. But other than that, yeah, like I said, it's relatively simple. So now we're going to go to lesson 4, and we're gonna make this dynamic. Again, we always want our students to feel like their application is doing something, right? It makes everything a hell of a lot more interesting. So basically with this, what we're going to do is we're going to create a text box, and then whatever information we put into that text box, we're then going to create a message box that has that information. So we're going to pass the value from the text box to a message box, and we get a little dynamism there. So let's go here. I will click on the play button as we do, and this is what we get. So text input app, process text label. This is a text box here. Then we have show message, and then we have exit, right? So we're gonna click this. We're gonna say, hello, students of the world, right? So we can type in whatever we want here. I'm then going to click on the show message. So this will create a message box from this value. And there we go. So this was, I think this was a show info instead of a show error. So message, hello students of the world. What this shows you is that you're able to input values into a text box. You're able to get those values from the text box, and then you're able to do something with it. Again, in the real world, we would be sending this to a database. We'd be sending this to a messaging API. You'd be doing something a little bit more cooler than this, but this kind of just starts to give you the idea of how the flow of these applications work. So with this, it's pretty simple. And of course, we have the exit button down there. You all know how the exit button works. So from tKinter, import all, and then what are we doing, boys and girls? Window.mainLoop. Import all, window.mainLoop. Eli, my script isn't working. Did you remember the main loop? Anyways, then of course, because our industry is full of passive-aggressive assets, after you import all, you then have to import the message box, because of course you do. Then we're going to window equals TK, as we've done. Window geometry is 400 by 200. And so you can see that might be a little bit small. We might want to make this window a little bit bigger here. So let me close this out just so you can see this. So let's say I just want to make sure the text box, oh no, it's going to fail on me, isn't it? Anyways, never mind, we're not going to do that. Anyways, if I wanted to make the text box bigger, I can make the text box bigger. Yeah, discard, go away. Okay, so let's see here. So we can make this bigger if we want to make this bigger. Window.title equals text input app, as we have here. Okay, label, so we're going to create that label value, label variable. LBL equals label. In window, text equals process text. We're then going to pack that variable. Now we're going to create the input. We're going to create that text input. txt underscore input equals the text function in window, height of 5, width of 52. For some reason, I don't know why I put 52. 52! Because of course. Now, one of the things I do want you to be thinking about is, remember, in the programming world, in the technology world, sometimes you can be talking about the same type of thing, but be using different measurements, right? So when we do geometry here, 400 by 200, that is pixels. That is pixels. Here, when we talk about height and width, this is rows and characters. Right? So it's five rows and 52 characters. So one of the issues you can kind of run into when you're trying to design something in tKinter is when you're trying to put in things like text boxes, trying to figure out what size the text box should be compared to what size the actual TK window is. That can run you into some problems. But anyways, it's pretty simple. That's all you do. The text function, you give it a height and you give it a width, and then you do text txt underscore input dot pack. So this is where we pack that, and we put it onto the screen. Then we're going to go down. We're going to create that alert box function again. So just like we did before. So define def space msg underscore alert. So this is our function name. Then we're going to do message box period show info. So again, show info, show error, show warning. We're doing the info. That just gives us that little light bulb thing. Then we're going to do message and then comma. And then we're going to do txt underscore input dot get. So we're going to get, right? We're going to get from text underscore input 1.0. Oh, that's so stupid. It's so stupid. So this is a placement for the text. This is a placement for the text. So when you're dealing with the technology world, we have the ordinal numbering system and the cardinal numbering system. One of them starts at 0, the other one starts at 1. So when you're dealing with hard drives, many times you'll start with hard drive 0. When you're dealing with addresses, many times you'll deal with 0, and other times you'll deal with 1, right? So it's ordinal, it's cardinal. And what normal people would do is they would pick one or the other. But that's not Python. That's not tKinter. So what this is for here, this is where do we begin getting something from this text box. So for some reason, you might want to get from the third line, from the fifth line, from 20 characters in on the second line. Again, it's coding. You can do whatever you want to do. So there might be some reason you want to do that. So what we're doing here is 1 equals the first row. So 1 is the first row. Period, 0 is the first character. So 1 equals first row, period, 0 equals first character, and so that gets us the first character in the first row. And again, like you're dealing with some kind of text input box, there might be something that's automatically added for some reason, like maybe like a command prompt type thing that automatically gets put in there. If you always know what's automatically getting put in there, you can just try to strip that out. You can do that here. Then after that, you do comma, and then after comma, you can either do end, END, or well, you can do a location. So you could say from 1.0 to 5.10 if you wanted, right? So from first position, first row, first character to the fifth row, 11th character. You could do that if you wanted. Most of the time, you do comma end. So END would take you all the way to the end. So get everything from the beginning to the end. But you'll notice here, I have end minus 1C. The reason for that is to understand, whenever you're dealing with anything in the programming world, understand what's actually occurring. And with a text box, by default, it always adds a next line character. So remember, in the text world, so plain text, not HTML, plain text, you have a /T for tab, /N for next line, right? That's where it tells it the basic formatting. So with text boxes, it always adds a next line character, even if you don't do it yourself. So what this says is go to the end, but then simply delete the last character from the end, which is the next line, because we don't want to process it. We don't want to deal with that, right? And so that is what will get us this message being printed out. Get from 1, 0 to end. But end would actually be down here, so it's -1 will just get us to the end of D. We do show message, and we get that hello world right there. We go down here, button, just like we dealt with before, btn_warn, button, in window, show message, command equals msg_alert, which is this function that we had just created, and then we're going to pack it. Then we're going to have a close, because we always want the exit button here, so we always want that exit button. So button close equals button in window, text exit, command window.destroy. Then we're going to pack it. Then we're going to do the main loop, and that's what gets us our fancy little GUI app that allows us to do some processing. So now for lesson 5, what we're going to do is we're going to take information from the end user, and then we're going to store it into what is called a CSV file, a comma separated value file. So if you want to store data, for your application, but you don't want to get to the point where you have to have a database, so a MySQL database, a Postgres database, that type of thing, one of the things you might use is something called a CSV file. Think of this as a very simple Excel file. Even in Excel, like Microsoft Excel, you can actually export to a CSV file, and essentially every comma area equals a column in that CSV file. So name would be in the first index, age would be in the second index, email address or whatever else would be in the third index. So what we're going to do with this particular project is we're going to create a little form that's going to ask, I think it's for name and age and an email address, and then we're going to dump that into a CSV file. So we're going to take all those variables that we got from the end user, we're going to add commas, so it then becomes a record so that it could then be processed by something else, right? So with this, let's hit the run button as we've been doing, and we get our little application here that says write to file, right? So let's say my name is Billy Bob. Let's say my age is 33 and my email address is bob@bob.com. Let me say, if you have the email address bob@bob.com, I highly apologize. I'm probably the reason you get so much spam. Quite literally, whenever I go to a website and they force you to give an email address, I always give bob@bob.com. And it always works. For like 20 years, it's worked. Anyways, what we're going to do now is we're going to simply save the data. And what you'll notice is nothing happens. Again, think about this from a UI, UX designer point of view. Is do I feel comfortable with this? If I don't actually see anything occur, do I think something's occurred? That'll be something for a different lesson. Anyways, what we're going to do here is we're going to go to the File Explorer. And what just got created is data.html, right? And so if I double click on data.html, we can see Billy Bob, 33, bob@bob.com. We have a CSV file. Now, I call this .html, again, from a student standpoint. You could do this in .txt or whatever else. I did this as .html just so it's very easy to open this up in something like Firefox, whatever your web browser is. And then as we change the values so that you can simply hit the refresh button to see what's going on, right? So I could say like Mary Sue is 22, and she's also bob@bob.com because it is the best email address out there. I can save the data, I can then refresh, and we can see Mary Sue, 22, bob@bob.com, right? This just kind of basically allows you to see that this is a dynamic change for you. So anyways, with that, let's go through and actually take a look at this code. So from tKinter, import all. So we don't have Messagebox or anything else, so we can just do the import all. Window equals tk. Actually, let me just pull this up so we can see this. Okay, so window equals tk, we've done that. Window.geometry, 400 by 200, we've done that. Window.title, right to file. Okay, that's pretty simple. Then what we're going to have here is this is going to be our function. And so with this function, what we're going to be doing is we're going to concatenate all the data from the different text files and turn that into one variable value so that we can save that to the file. So define, so this is a function, so def space write parentheses colon. Then we're going to say data. So data equals, data is what we're going to be writing to the file. Data equals txt underscore name dot get. So go to this text field, get from first line, first character to end -1 character. Then we're concatenating here, so we're going to do plus, double quotation marks, comma, double quotation marks, right? So first value, comma. Then we simply do text underscore age, get 1.0 to end, right? Plus, comma. So name, comma, age, comma, tx plus txt underscore email dot get 1.0 to end -1c. And so what it's going to do is going to do name, comma, age, comma, email address, nothing. And that is going to be for the value for the variable data. Pretty simple right there, right? File equals open data.html as overwrite, W. So do be careful with this. This is one of the things to be thinking about whenever you're dealing with programming. Do you want to do overwrite or do you want to do append? I'm just overwriting here since we're not actually using the data for anything. File.write data. So this concatenated string that we created is going to be overwritten. It's going to write over anything that's currently in data.html, and then we are going to close the file. Always make sure to close your file in Python or you start to get some weird problems. Past that, it's all pretty simple, right? So label name, so the label name is there, equals window, so so the label function in window text equals name. Now, one of the things you can see here is that I did .pack without the additional .pack. So text name, I did the pack function afterwards. For the label, I did the pack function in line. So I want to show you that you can do this. The issue that you run into is anything that you modify or anything that you touch in tKinter, the pack function has to be separate from when you create the variable value, right? So with these text boxes, since you're going to be touching that, you're going to touch that, you need to pack it later. Entry fields. We're going to have, that kind of thing. Anything they're going to be messing with, you need to pack later. There's something about tKinter for some reason. If you have something like a label that you're not going to touch, tKinter isn't going to touch it. It's not going to read it. It's not going to do anything with it. You can actually pack it in line. So again, label name, window, text, dot pack, you can do that in line. But if you're dealing with text, entry, label boxes, anything like that, you need to pack it separately. txt underscore name equals the text function in window, height of 1, width of 20. And then we're going to do txt underscore name dot pack. So the label packed in line, the text box packed separately. Then it's pretty simple here. LBL age packed in line, text for age, txt underscore age, that's going to be, packed separately. Label email in line, text email packed separately. Then what we have here is btn underscore write, so the write button. In window, text equals save data, command equals write, so just the name of the function, nothing else, no parentheses. Then we're going to button pack afterwards. So then when we click on this button, it is then going to call this function that we created up here. Then, of course, we have the exit button, so btn close, window, text exit, command equals window.destroy, and then always remember to have the main loop. And so this allows us to have our users input data. It then saves that into a CSV file so that we can process it later. So there you go. In only 5 lessons, you've started to do something that might actually be slightly useful for you at the end of the day. Now going into lesson 6, what I want to show you how to do is we're going to add values to a text file. We're then going to read values from that text file and output it into a text box that we've created. And basically with this, we're simulating something like a note-taking app. So I can write a little note, I can add that note, and then it'll simply add to this ever-expanding text box. Again, if you're following along at home, this code is getting longer and longer, so I would highly recommend that you print out this code or have this code at least on a different screen while you're watching this video, because it does start to get to be a bit of a disaster, kind of scrolling back and forth. I think that'll be easier for you. Anyways, so here we have our script 6.py. We're going to run this script, and when we run this script, we get our nice little note-taking app, right? This could be something useful. Let's see, a new note. So I have an idea for a note. I write my new note, I click Save Note, and there is a new note. But I have another idea. So what if I want to do another idea for a note? Now I can add that. Oh, there was another idea for a note. And what if I want, even more ideas? I can click the Save Note, right? And it pops up here. One of the important things to understand about this is that this is static. This is actually being written to a text file. So if I go down here and I click on Exit, then I click on Run again, we will see that my notes continue to exist. And so again, that's one of the useful things with this app. So like when you added the message before for that message box, when you do some of those other things, if you're not actually saving to a file, when you shut down the application, anything that you added goes away. The cool part about this is you're writing from a text file, you're reading from a text file, so therefore even if you reboot the computer, all of that information continues to exist. So this is pretty cool here. So anyways, okay, so from tKinter, import all, and then we scroll all the way down and do window.mainLoop. Always remember main loop. Eli, why is it not working? Have you looked at the main loop? I guarantee you. Anyways, window equals TK, as has been. Window.geometry is 400 by 600, so maybe that's a little bit long, whatever. And the window.title equals node app. Okay, that's all pretty simple there. So here we're going to create the writing function. So when we write, define write function, data equals text underscore note. So basically we're going to have this text box here. So go to that text box and get from the first row, first character 1.0 to end -1 character. And then plus, we're actually going to put in our own next line character here. I don't know. Is this the best way to do this? I got called out in my class when I showed them this. And they're like, Eli, aren't you removing the next line character only to add the next line character? And I was like, maybe. Maybe. Have you ever tried to teach noobs? Anyways, this works. If you want to just do end, if you just want to do comma, end, E-N-D, all uppercase, you can try that, see if it functions for you properly. I did this because this works every time. I don't get paid to troubleshoot. So anyways, so again, this is one of those things you get into sometimes weird things with coding. Sometimes you rip things out only to add them back. And then, I don't know, is it the best way? Maybe not. Anyways, file equals open note.txt, comma A. So A is for append. It will just continually add. One of the problems with this particular note-taking app is there is no way to delete anything other than deleting the actual note.txt file. So kind of something to keep in mind. File.write data. So basically, write the data value into the note.txt, file.close, and then text underscore note.delete 1.0 to end. So see end here, so end is to the end. What that is for is so when I add something into this text box and I save it, it goes away, right? That's one of those things from a user interface design that shows the user that something happened. Also make sure they don't continuously keep inputting the same crap. And then from here, after we've written, we're then going to call the read function that is down here. Why we call the read function is because we want this to auto update, right? So when I add a note, not only do I want the note to delete from here, but I want this to automatically refresh itself, right? So when we do this, that gets deleted, that gets written. And so that's why we want this read function here, because this is coming from the read function. So when the write function happens, delete, write to the file, and then have read, reread from the file to show us what's going on in the text box. Then we come down here to the read function. So read, txt underscore read. So this is the read text box, right? .config state equals normal. So what this means is we are currently, for a brief amount of time, making this text box writable. So this right here, this is a text box. And what do you do in a text box? You type in a text box. What if you want to make it so the text box is only displaying something, but people can't add to it, can't screw around with it, right? If you want to make it so people are not able to write to a text box, you can do .config state equals disabled, and then that means you can't actually type anything in the text box. So that gives us a good way of displaying a lot of information without people doing weird crap with it, right? So anyways, but to be able to write to the text box, we actually have to put it to a state of normal. So the read text box config state equals normal. Then what we're going to do is we're going to delete everything. Again, remember in the technology world, nothing is magical. If we don't delete everything and we simply tell it to write, what's it going to do? It's going to continuously write. It's going to continually add. So you have this block of text, and then it's going to add a new value and do a whole new block of text and a whole new block of text and a whole new block of text. If you want to see something interesting, right? If you want to see something interesting, you can simply just comment this out, put a pound sign there, comment that out, and see what happens. It'll be a bit of a disaster. So what we want to do is we just want to delete everything out of that text box. Create file equals open note.txt a+. So what this is going to do is this is actually going to create a file for us if the file doesn't exist. So append means append to a file. The plus, what the plus does is it actually creates a file if it doesn't currently exist. And so we're going to simply put this little create file thing here just so that it creates the file if it doesn't necessarily exist. Then file read equals open note.txt in read in R. Notes equal file underscore read dot read. So an important thing to understand here is with the dot read, so there's dot read lines. So when you're reading from a file in Python, you can do dot read lines. What dot read lines does is it reads into a list, right? So kind of like an array, a list. So one index. There's a line in index 0, a line in index 1, a line in index 2, and you can kind of loop through that. A read, what read does is it simply reads everything in the text file into one massive string. So that's why we're using in the right, that's why we're using these next lines here. So theoretically, we could loop through, right? So if we did the file.read lines, that goes into a list, and then we could do 4x in list and loop through. Could do that. That's not what we're doing here. I'm simply creating one big old string with the next line values in it, and then that's what we're going to be printing out. So read. Okay, and then text. Oh, this keeps happening. This keeps happening. Oh, why? Why? Oh, you ever have those days? Okay, power supplies pulls out. Anyways. I swear I'm a professional. I've been doing computers so long. So long. Okay, where were we at here? Okay, so we're going to read. We're going to read into a string. So notes is going to be one big ass string. Every note is going to be separated by a /n, a new line. Then what we're going to do is we're going to do text underscore read. So that text box insert at first line, first character, the value of notes. So it's simply going to dump everything in there, and it gets formatted that way because it's /n. Then what we're going to do is file read.close. So we're going to close the file that we opened up here. We always make sure to close. And then we're going to do text underscore read config. We're going to disable so that people are not able to type into that box anymore, right? So basically what's going to happen here is we're going to make the text box normal state so that it can be written to. We're going to then delete everything in the text box. We're going to create the note.txt file if it does not exist, since we're reading from it. We're then going to close that. We're then going to read from the file, so file underscore read equals open the note.txt file. We're then going to take everything from that file, put it into one string. All the values are separated by /n, that next line character. We're then going to insert from the first row, the first character position, everything that's in notes. We're then going to close the file that we were reading. We are then going to change the configuration back to disabled so nobody can modify anything in there. All right, that's basically all there is to it. Then we go down here, and let's see here. So we have label. Oops. Let's see if we can just kind of put this over here. So we have label, new note.pack. So we have the new note label up there, and we're packing it in line. Then we have text note, text in window, height of 1 width of 40. We're going to pack that separately. So that's what that is. Then we're going to have a button. The button is save note, command right? And then we're going to pack it. And so that is going to be there. Then we're going to the text box, right? Text read, so the readable text box in window, height of 20, width of 40. to make it bigger. Then we're going to pack it. Then what we're going to do here is we're going to call the read function. Right? So basically by calling the read function here, as soon as we open the script, that read function will initially fire so that we can see what's going on, right? So it's not currently open. So with this, we're going to open this up, and then this is already pre-populated. The reason that this is already pre-populated is because in the main area of our script, we call the read function here. So basically, the script is going along, and then it goes here. Now, when we save a note, right, so when we click the Save Note button, we go to the write function, we get all the way to the end of the write function, and then we hit the read function, so that auto refreshes what's in this text box. But then that initial, when we initially open up this application, we need something to be here in this text box, and so that's why we're calling it here. Then we're going to have the button close, as we always do. Text equals exit, Windows destroy. We're then going to pack that button, and then of course we're going to have the final main loop. So this is where we're able to write to a file, we're able to read from that file, and again, there's some UI UX things I want you to be thinking about here. Basically the idea of once somebody submits information from a text box, deleting whatever's in that text box, right? So there's something that the user sees to know that something has actually occurred. Also, something to be thinking about is refreshing whatever display box you have. Just because you put information into the text file that display box is pulling from, until you do some kind of refresh, that text box isn't actually going to be showing anything. Also, that final thing, where I have this read function here, also think about when you initially open up the application, what's going to initially show in that text box. These are just little UI UX things that you should be considering, but this kind of gives you an idea of the basics of how this works. So up until this point, we've been dealing with text boxes, but what if we wanted a pre-selected set of values? So with this particular lesson, we're going to be dealing with a list box. Basically, it looks like a text box, only it has different values, and you're able to select on those values and then process based off of whatever you've selected. If we go here, we click on the Run button. This is our little Listbox app that we're creating here. Basically, these are different names in the list box, so Bob, Sue, Frank, and Fred. I can click on a name and I can print the name. So basically what this is showing you is you're displaying the values. You know, in the list box, you're able to select on a value in the list box, and then when you click on the button, you're able to grab that value and do something with it. At this point, we've already written to text files, we've already written to CSV files, we've already written to message boxes and that kind of thing. So at this point, we're going to try to make it just a little bit simpler so you get the idea without worrying about a lot of extraneous code. So with this is all relatively simple. So we're going to do from tKinter, import all, and you're going to get tired of me saying it, but then we're going to do window.mainLoop. Always make sure you do that. Why isn't it running? Make sure you did the main loop. Let's see here. Okay, then we're going to do window equals TK, window geometry equals 400 by 300, window title equals list box. Okay, at this point, we're then going to create our print function. So the print function is going to print out to this text box. Text equals LB, so the list box. So we're going to create a list box here, LB equals list box. So text is going to equal listbox.get anchor. So what anchor means is whatever it is I'm selecting here. So Frank is the anchor, Patty is the anchor, right? So that's basically all you have to do. So the text is going to equal listbox get, essentially whatever is highlighted. We call that by using anchor. txt underscore name dot delete 1.0 to end. So what this is going to do is in the text box, it's going to delete everything. Right, so that is a clean box so we can write to, and then we're simply going to do txt underscore name dot insert 1.0 and then the value of text, right? So with this, I click on Frank, I hit the Frank button, it deletes Patty, and then it writes Frank. Pretty simple. We're going to go down here, and the first thing that we're going to do is we're going to create our list box. So LB equals list box in window. Do remember, whenever you're dealing with these widgets, almost always you have to say where the hell the widget is showing up. So we'll do an entire other class with this, with a little bit more formatting in tKinter. So you have windows, you can actually have frames within windows, you can do some pretty complicated formatting. Again, we're just doing window here. So LB equals listbox in window, LB pack. Right? Then, in order to get the values in the list box, we are simply going to use insert. So LB period insert, and then we have to say the index, so 0, 1, 2, 3, 4, all the way to 500, and then whatever the value is that should be in that index. So LB insert at 0, Bob. LB insert at 1, Sue. LB insert at 2, Frank. LB insert at 3, Fred. LB insert at 4, Patty. Now you'll see how this is. This is very easy to put into a loop, right? So you could have some kind of 4x loop where you go to a list in a database or a list in a text file, and let's say something like states. Right? Let's say you want to, what state is somebody from? So you could have every state in a text list, and you could say 4x in state, lb.insert 0, x, lb.insert 1, x, right? So it would actually flesh out this list box with all of those different states. That is something that is very easy to do. Let's see, button underscore ping. Anyways, I'm a real geek. I was working on this with something else. We're going to do another project in a second. But anyways, this button underscore ping is print name, actually. So this is just a variable value. It should be called print name or something. So anyways, this button equals button in window, text equals print name, command equals print. So when I click on this button, this print function is going to work. Whatever the button's name is, even if I left an old button name in there. Then button underscore ping dot pack. So that's going to pack the button. Then we're going to have text under txt underscore name equals a text box in window, height of 1, width of 25, and then we're going to pack it. Then we're going to have a button of close. We're going to do the window dot destroy like we normally do, and then we're going to have the window dot main loop. So this really all there is to a list box. So with a list box, you create it LB, so whatever the name is, equals list box in the window where it's going to be located. To insert into the list box, you simply call the list box name dot insert, add an index number, whatever the value is, and then that gives you those values. If you then want to process based off of the value that is currently selected, you're able to get that from LB, so the listbox name dot get, and then anchor. Anchor is what gives you that value, and there you go. That's basically how list boxes work for you. Now the final project for the regular class actually gives us something that's sort of useful. I mean, you can just go to the command line and do it, but it's a real app that does something that's actually functional, right? And basically what we're going to be doing here is we're going to be creating a ping app. So we're going to be able to give our little app a fully qualified domain name or an IP address. So cnn.com or 192.168.1.1. We're going to hit the little go button. It is then going to ping that IP address or fully qualified domain name once, and then it's going to return the value to us and show it to us on the screen. So this actually theoretically could be useful, even though there's probably easier ways to get it done, right? So if I hit on the run button, this is our little ping app that is created, sites to test. So I can type in cnn.com, I can click ping, And there we go. So I pinged it once. CNN.com is at 151.101.195.5. One packet received. It gives me some of this other information. So it shows me that that actually works, right? If I want to ping 192.168.1.1. Actually, I don't think that's a subnet mask I'm on here. Anyways, so I try to ping that, and I actually do get a response. I don't know. What if I try to ping 100? I try to ping 100. Okay, it's failing out. So it should give me something in a second. Here's a question. How long does it take for it to fail out? Okay, yeah, it just failed out. Didn't actually give us any errors or anything like that. So this is an ability for us to give a value to our little script. It then actually takes that value and runs an operating system level command. It then takes basically whatever the response is from the operating system and prints it up to this particular screen. So again, this is something that can actually be used in the real world and comes to about 28 lines of code. So with this, from tKinter, import all, as we normally do. Then we're going to import subprocess. So subprocess is a module that allows us to actually interact with the operating system. This is a huge thing in the programming world, right? One of the reasons why noobs give up. To be clear, they do not fail. Most noobs do not fail. Most noobs give up. And the reason that they give up is because they always try to reinvent the wheel. It's amazing. It's amazing what noobs try to do. And you just look at them and you're like, why? Eli, I'm not smart. I can't recreate the ping application. And it's like, why would you recreate? Just use ping. Ping has already been created, right? But this is a big thing. Again, that's where, we're about to have a class here on ChatGPT. And again, one of my buzzwords is AI is hard. APIs are not, right? That's the thing. Trying to figure out artificial intelligence, the people at OpenAI are brilliant, right? To actually get value from ChatGPT and OpenAI, you need 3 lines of code, right? And so that's one of the big things to be thinking about whenever you're creating your program is, can you interact with something that somebody else created so that you can get that value, you can get those resources essentially with a single line of code, right? So anyways, what subprocess allows us to do is it allows us to interact with the operating system. And when we interact with the operating system, we get ping, we get tracert, we get top, we get all this basic like troubleshooting diagnostic tools that are built into Linux, or additional tools that you can add to Linux that are already built in there. And then we can get the power of that. And again, not try to reinvent the darn wheel. Again, if you're sitting there and you're about to give up, right? Something is so complicated and so hard and you're about to give up, ask yourself, am I trying to reinvent the wheel? Maybe somebody already created a wheel and I can just use the wheel that they created. Again, it's a big problem. Anyways, so window equals tk, as always. Window.geometry, 550 by 250, so it makes this a little bit bigger so you can actually see everything. Window.title, ping app, as we've had before. Okay, then we get to the ping function. So def space ping. So FQDN, if you're not used to the networking world, basically this is what's called a fully qualified domain name. So something like CNN.com, FoxNews.com, Breitbart.com. Look, I just say CNN.com. I swear to you, back in 2009, I started saying CNN.com long before so many things have happened in this world. And I just keep saying CNN.com because I've done it for the past 14 years. Anyways, fully qualified domain name, just CNN.com or whatever else, right? So FQDN equals txt_ping.get. So with this, all we're doing is we're simply going to go to the text file and we're just going to get everything in the text file. It'll be fine for us. FQDN equals FQDN. So fully qualified domain name that we got, period strip. So this is an important thing. So what if people added spaces? So if you add spaces around something like a domain name, that might cause you some problems. So we're simply going to be stripping out those white spaces there. Then we're going to create the command. So this is the command that is going to be sent to the operating system. Now, one of the big things to understand, especially if you're coming from the Windows world, is the Windows by default fails you out of things. So when you ping, at least how you used to ping, if I said ping cnn.com in Windows, it would ping 4 times and then it would stop. That is not the case for Linux or for Macs or for Unix. If you start pinging, it will keep pinging until you manually stop it, right? And so remember, with any of these kind of commands, especially when you're interacting with the operating system, the script will not continue until it gets a response. So if you ping once and it gives you a response, then it continues. Even if it fails out, it continues. If you tell it to ping, and you don't give it a set number of times to ping, it will just keep pinging, and then your application essentially freezes up because it never gets the response from the operating system. So with here, what we're doing is we're doing command equals, and then we're going to say ping space -c. So -c is count, and then we're simply going to do 1. So ping space count 1, and then space, make sure there's a space here, plus FQDN. So if you put the double quotation mark directly on the 1, then it'll be ping -c 11192, right? That's not going to work. So make sure you put the space in there, and that'll create the entire command. Then output equals sub process. So we're calling that sub process function. Check output command shell equals true. So we're going to ping command equals true. And then we're simply going to say label result dot config. So the label, this label result that we have here, dot config, the text is going to equal whatever that output value is, right? Pretty simple. So dot config and then text equals output. That will refresh whatever the value is in the label. We have label ping. So the ping label up there in Windows cites the test, and we pack it all in line because we're not going to mess with it. Text underscore ping. Here we're actually doing an entry value. Instead of being a text box, we're doing an entry value. So an entry value is one single line of a human inputted value, and that's it. So like with text, you can make it 100 lines by 50 characters or whatever else. Entry is actually just one single line. So a lot of times that's a little bit more useful. And then we're going to pack. And we're going to pack it. Then we have the label result. When we first open this up, it says ping to see results. That's what the initial text is. And then label result pack. So that is going to get changed here. So label result dot config text equals output. Then we're going to the button ping. So remember that ping button we had in the last lesson? Yeah, this is where it came from. Button ping equals button in the window. Text equals ping. Command equals ping. And then we're going to pack it. And then we're going to close. Then we're going to have the close button. Then we're going to pack the close button. And then we're going to have the main loop. So that is basically what this looks like here. So it's relatively simple. Using subprocess, we're able to interact with the operating system. Using concatenation, we're able to take the value from that entry box, add it with whatever command we want for the operating system. We are then able to check the output and go from there. That's the other thing here. I'm sorry, with a fully qualified domain name, text underscore ping dot get. The reason we're doing get here without the 1.0 to end or 1.0 to end -1c is because we're using an entry box, and the entry box doesn't require that. So that's why that's here in this particular script. So there you go. There you go. You got a little bit of a useful application from the end of this class. But wait, there's more. Don't you want extra credit? No, Eli, we don't want extra credit. So anyways, this is an extra credit lab assignment that I added to the class. To be clear, the eight labs that we just did were enough for a 2 to 3 hour hands-on class. Doing any more probably would have melted my students' brains, but I did think, hey, I think this is kind of an interesting extra credit assignment for anybody that wants to take this home and do this on their own lab computer. And basically what this allows us to do is this allows us to add a list box. So what we're going to be able to do is we're going to be able to add values to a list box. We're then going to be able to select a value from the list box, and then we're going to ping it, right? So let me go and run our little extra credit program here. And what's going on? Oh, close that out. Okay, there we go. So this is our extra credit program. So what we can do here is we can add fully qualified domain names or IP addresses here separated by commas. So we can do cnn.com, comma, Fox, let's do news. Let's be fair and balanced. Do foxnews.com, comma, tacobell.com, comma, 192.168.1.1. And we click on edit sites. And what we were able to do is we're able to take all the values that we put in here that were comma separated values. We're able to separate them out, and we're able to put them onto individual lines within this list box. So this might be useful for you, again, if you're in doing tech support and you have a number of different sites that you have to ping every once in a while. Maybe you use Salesforce. Again, you use specific servers, whatever. You could kind of add them all into one little list box like this. And then if you just want to see, what the status of that particular, site is, we can go down here. We can click on ping. And so we can see ping Fox News at 23.198.217.18. One packet transmitted, one packet received. We get that information. If I click on Taco Bell and I ping Taco Bell, so we see that this is dynamic, 23.73.207.9, one packet transmitted, one packet received, so on and so forth. Fair and balanced, let's be fair and balanced. CNN, we ping CNN, we get a response from CNN. And so what this particular lab is showing us is that we can take in values from a text box. If we separate them by commas, those are comma separated values, so we can then parse that, then basically write those individual values into a list box, and then with those individual values, we can then trigger an operating system command, for something to happen. Let's see here. If we go over, we take a look at this. It's not too long. It's 43 lines of code for this particular thing. So from tKinter, import all, and then import sub-process. Again, that is the module that allows us to interact with the operating system. Window equals tk, window.geometry, 400 by 600, window.title, ping app. Then if we look at the basically list box update, so the function for LB underscore update, list underscore ping. So we're going to be updating this particular box. TXT underscore ping get. So it's a text box from 1.0 to end minus 1C. So from the end minus one character. Then list ping, what we're going to do is split. So what the split function does is it turns a string into a list based off of the character you give it. So you could split a string into a list based off of spaces. You could give it different delimiters, colons, or that kind of thing. Anyways, it's a comma separated value. So we're simply going to split based off of the commas. So this is going to be list underscore ping is simply going to be a string of the values coming in from the text underscore ping text box. Then we're going to turn that into a list by splitting it with comma. Then we're going to do listbox LB. We're going to delete from 0 to end. So again, whenever you're dealing with any kind of box, you're going to be adding information to it. Make sure what you're doing, most of the time you're going to have to delete everything. If you don't delete everything, you're just going to keep overwriting. Then we're going to do index equals 0. So this is where we can have a list. So you can actually use something called the enumerate function. There's a function called enumerate where you'd say for count, comma, value, and then it's enumerate, parentheses, and then whatever the list is, and that gives you an easy enumeration. I'm simply doing the index here, right? So index equals 0. So index equals 0 for x in list underscore ping. So for all the different indexes in the list, x equals x dot strip. So again, I want to strip out the white space. Strip strips out white space, and then lb dot insert whatever the value of index is, so it's currently 0, and whatever the first item here is, right? So CNN. So at the 0 index, put in CNN. Index plus equals, so basically increment by 1, so index is now 1. So we go back through the loop, x strip, insert into index 1, foxnews.com, add 1 to index. Insert into spot 2, tacobell.com, right? And that's the loop, and that's where we can auto add to a list box. Again, one of the values of this. Then we have the ping function here. Same ping function that we had before. Fully qualified domain name equals lb.getAnchor. So again, we're dealing with a list box now instead of an entry box. So anchor, get anchor, that gets essentially whatever is currently selected. Command equals ping space -c space 1 space, make sure there's a space, plus fully qualified domain name. That gives us ping space c space 1 space cnn.com. Output equals subprocess check output command, that command that we created, shell equals true. And then lbl result dot config text equals output. So this is LBL result, and we're just simply going to make that text whatever the value of the output is. We come down here, label ping, sites to test and pack. So sites to test, right? That's that label right there. Text ping equals, so this is a text box. So again, not an entry box. You're now going back to a text box. Height of 1, width of 40. We're then going to pack down here because we're going to be dealing with that text box. Button update. So button update here in window, text equals edit sites. Command equals lb update. So that is going to basically, when you click on that button, it's going to delete everything that's currently in that box and then add whatever you've added. Then we're going to come down here to LB equals listbox window. So this is the list box here, and then we're going to pack underneath. And then we're going to do LBL underscore result in window, text equals ping to see results. So initially it says ping to see results. That will get modified as soon as we ping something the first time, right? So if we exit out, and then if we run this, you see initially it says ping to see results. And then we add CNN.com and FoxNews.com because we're fair and balanced, right? And so then when I select one and I hit ping, now we get that, right? Now we'll notice here with this label, right? So label ping, I packed in line. So sites to test, I packed in line because I'm no longer going to mess with it. What you'll notice here is the label results, I packed underneath because I will be modifying it. Anything that we're going to be touching with TK, with tKinter, you pack separately. Then we have the button ping command. So basically with this, in window, text equals ping, command equals ping as we've dealt with before. We have the close, destroy the window, and then we have the main loop. And that's what gets us this particular little script that again becomes slightly more useful. But you start to understand, right? How do you get values from a text box? How do you then parse them into something like a list? How do you then auto add that into the list box that we've created? How do we use that list box in order to send a command, grab the values from a command, print that into a label here, and then obviously have the exit button. So this is a little bit more of extra credit. If you're going to be teaching this to your students, I would recommend you give them extra credit on this. Whew. There's a lot of code for this particular class, and I do feel like this is a bit of a bridge too far during the normal in-class sessions that we're doing. There you go! You survived! Yay! Now you have a bit of an idea of how to use tKinter to create GUI applications with Python. This is really, 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 really cool because basically what this means is you can use the power of Python and basically you can wrap it into something that the average user actually thinks of as a quote-unquote real computer program, right? You can have the most powerful command line utility in the world, and if you give it to a user or you give it to a noob student, they're gonna be like, well, I guess if we're using this cheap garbage, right? You give them a couple of buttons and list boxes, they'll be over the moon. So that's what you're able to do. Again, with tKinter, there's a lot of stuff that you can do with tKinter. You can add images to tKinter. You can add video streams to tKinter. Most anything that you'd be dealing with a normal graphical user interface application, you can do with tKinter. So we're going to have a lot more classes around the concept of tKinter. Again, we're going to have a class just on how to format things. That's a big thing. Like one of the big issues that you do run into with tKinter is since you have, it's like you have text, but that text outputs to a visual format. And so figuring out how to write the text to make it look visually pretty can be a real pain in the butt. So we will have a class specifically on that. We'll also have a class on wireframing tools, possibly on something called Figma, that basically gives you a graphical user interface to create the code. So instead of writing the code to create the graphical user interface, you can actually create the graphical user interface using WYSIWYG tools. What you see is what you get tools that will then create the back-end code for you. So we'll have classes on that. And we're just going to do a lot of stuff with tKinter because this is just a very easy way to create interactive applications that doesn't need anything else. You don't need an additional web server. You don't need to figure out how the hell to use Django, any of that kind of thing. So that's one of the reasons I think tKinter not only is powerful in the real world, but again, especially is powerful in this Silicon Dojo environment and why it's going to be so useful. Now, one of the things I will remind you is that Python is an interpreted programming language. And so one thing is between the different operating systems, things might be interpreted slightly differently when you deal with something like tKinter. So tKinter, right? So you have the Python script that then creates the visual, whatever you're looking at. Well, that visual, whatever you're looking at, there's a lot of underlying resources and libraries that come from the operating system. So sometimes what you see on Ubuntu is going to look different, slightly different than what you see on Mac, which is going to be different than what you see on Windows, right? It's kind of like with web browsers, especially if you looked at web browsers like 10 years ago, not necessarily now. Most websites look the same across all web browsers, but my golly, you go back like 10, 12 years ago, you opened up a website on Internet Explorer, on Safari, on Chrome and Firefox, and it was the same website, sort of, had the same information, definitely looked differently. Literally, had a grandma. Oh my golly, these kids really wanted to look out for their aging mother, and so the aging mother had a crappy Windows computer. Really did have a crappy Windows computer. So they bought her a brand new Mac system. And again, you're going back 10, 12 years ago. These things were bloody expensive, but they just wanted a system that the grandmother wouldn't have to worry about viruses, wouldn't have to worry about anything else. The computer would just work, right? So anyways, the only thing this woman cared about, the only thing in the world this woman cared about was the New York Times. New York Times was it. And again, this was 12 years ago, before the Now Times. And anyway, so I spend an hour or two, I migrate all the data, I do all the setup, and she's like, okay, let me just pull up New York Times, and then as soon as I see New York Times, I'll let you go. And so she pulled up New York Times. Oh, this isn't New York Times. No, Eli, no, I need New York Times. I'm like, but it is New York Times. No, this isn't New York Times. Eli, I need New York Times, right? And the reason is because it was Mac, and back then you could basically only use Safari as a web browser, and New York Times looked different on Safari. Then I looked at Internet Explorer, and all hell ensued. That became a very bad day for me. I truly Getting into arguments with CEOs, that can actually be kind of fun. Honestly, gotta say, can be kind of fun. Little screaming match between, CXO level executives. That's a good old time. Sitting there with a grandma and trying to explain, but no, this is the New York Times. That's not fun. That is what I call a miserable experience. Why I bring that up is since it's interpreted, when these apps that I showed you pop up, whether it's Mac, whether it's Ubuntu, whether it's Windows, the functionality will be the same. But visually, it'll look a little bit different. Like when I did that message box, right? Show warning, show error, show info. Well, and you saw how there was a little graphic there. Like there's a little light bulb graphic or a little warning sign graphic. Those graphics are different depending upon the operating system. So just something to realize is you could write this, you deploy the exact same code to a different operating system, and how it appears, again, won't be horribly different, but it might be enough different to have your users, drive you insane. The other thing that I noticed too is between the Mac and the Ubuntu systems, with the Ubuntu, I actually had to increase the size of the windows before I did the class today on the Mac, because when I did on the Mac, everything was fine, everything fit within the windows that I had created. And then curiously enough, when I loaded everything onto the Ubuntu system, should be the same, but many times it would actually cut off the bottom buttons. So I'd have to kind of like drag, and I'd have to like grab the bottom of the screen and pull it down in order to see the buttons that were at the bottom. So that is actually something that you might run into a real issue with, is if you don't look at the window sizing and that type of thing. If you don't test this on the multiple operating systems you might use the app on, you might get some of these weird kind of formatting errors. So it's the modern world of, multi-operating system programming. Test, and then buy a 6-pack of beer because the users are still going to make you lose your mind. Well, if somebody had tested this properly, we spent months testing this. We didn't think anybody would care about the GIF for a light bulb. Why does anybody care about the image for a light bulb? It's an image. But his image is different than my image. Who cares? It's a light bulb. It doesn't freaking matter. Anyways. Oh. Real world of being a technology professional. So yeah, I hope you had enjoyed this particular class. Again, all of this information should be on silicondojo.com, or it may be on our GitHub site. Again, videos last forever, so where the information is documented when you're watching this might be slightly different, but at least this point in time, it should be on silicondojo.com. Do remember, again, with these classes, they are free to the end user. If you're watching this on YouTube, YouTube does not pay me very much money anymore. Now that I've started doing real technology videos again, my channel is well and truly dying. So if you like this kind of stuff, do remember I do work for tips, so that donor box link it does actually matter to what we're trying to do here. If you're interested in coming to our classes, we're currently using Meetup as our RSVP system. So if you go to silicondojo.com, you click on Meetup, should be on like the right-hand side. Currently, it's on the right-hand side. That'll drop you in. You can RSVP for our classes. Again, the only thing that I ask is that you actually show up. These are all in-person classes. If you want online, this is what you get online. If you want in person, you can come. Again, they're free to the end user. They're authorityless, gatekeeperless. Basically, you sign up and you show up. Our only rule is quite literally play nice. You play nice, you get to learn technology in a pretty cool environment, right? I think it's a pretty simple thing that we have here. So if you're interested in coming, do take a look at that. Again, depending on when you're watching this class, we may no longer be using Meetup as the RSVP system. So go to silicondojo.com and see what we have set up there. But yeah, that's basically about all I've got for today. So as always, I enjoyed teaching this particular class. I look forward, hopefully to see you here in Asheville, North Carolina, or if not, look forward to seeing you back here on YouTube or whatever video platform the next time you watch a class.